Okay, good morning guys. Today we are going to be looking at the practical relationship between voltage, current and resistance. Now Ohm's law states that increase in voltage equal increase in current and equal decrease in resistance. So if voltage increases, current will increase across the resistor, which indirectly means that the resistance of that resistor has decreased due to voltage. So we are going to check out practically if Ohm's law is true. This is a circuit having three different voltage: 3.7 volts, 7.4 volts and 12 volts. We are not using the 15 volts, 12 volts. So across these two pins is 3.7 volts, and across this pin and this pin is 7.4 volts, and across this pin and this pin is 12 volts. In our circuit here we have a resistor of 1000 ohms connected to the negative pin of an LED. The end of the resistor is connected to the negative pin of the power source, the battery, and then the positive pin of the LED is connected to the positive pin of plus 3.7 volts. Now, according to Ohm's law again, it states that increase in voltage will increase the current across a resistor, a fixed resistor. Note that increase in voltage will increase the current across a fixed resistor, which means that the resistance decreases or increases depending on the input voltage applied to the circuit. We are going to check that out and see if it's true. This is the positive pin. At first it was connected to 3.7 plus 3.7 and minus 3.7. So you are seeing the brightness of the pin. You're seeing the brightness. Now I'm going to move this positive pin to plus 4.7 and check out the brightness of the LED. So here is 7.4 volts. If you look at it, you'll see that the brightness of this LED have increased. So let me move it back to 3.7. You see the brightness. Let me wave the light away so that you see. Now see the brightness. I'm going to move it to plus 7.4 volts and let's see the new brightness. You can see the difference. This is the brightness at 3.7 volts and this is the brightness at 7.4 volts. So let's move it across to 12 volts and see the next brightness. Now you can see the difference is about blowing up. So which means that Ohm's law is true. See the brightness at 7.4 volts and brightness at 3.7 volts, brightness at 4.7 volts and brightness at 12 volts. So Ohm's law is true. So what does this mean to a circuit designer? Whenever you are designing your circuit or whenever you are about to design a circuit, one of the things you have to consider is a stable voltage at each point or each part of the circuit. When voltage fluctuates in your circuit is likely to malfunction. So when you are building a circuit, right from the total voltage of the power source, you have to be able to determine voltage at each point. That is why in circuit like digital circuit, which are some part of a digital circuit requires stable voltage to run to keep doing the same thing for a longer time, you see them split. At a particular point takes 5 volts, at a particular point takes 3 volts, at a particular point take 1 volt. Why is that like that? So that because the total voltage of the battery keep decreasing. So if I have like a 12 volt running a device, which in between the device, the circuits of that device, voltage are being split, it means that for this device to run to run or keep doing the same thing for a certain amount of time, I have to be able to maintain that voltage for a certain amount of time. So I choose to use an higher voltage at the input, step it down to a lower voltage for the actual system to work. So by the time this voltage keep running and running and running, that time it runs till it gets to its 5 volts, the system will be able to keep doing the same thing for a longer time. So it means that your voltage, change in voltage in your circuit, can affect the behavior of your circuit.